And hello to everyone here and online. So actually, I will give you a few lessons from economic research concerning how carbon farming can provide credits for climate policy purposes. And if you think we have already heard that the carbon farming has a high potential to sequester carbon in soils. Current discussions in the EU reflect this thing because it has been discussed that carbon farming could contribute about 50 million tons to the becoming a new or renewed target for the EU sinks has been thought to be 310 million tons, meaning that it's 1/6 of the planned target. So that means that if carbon farming becomes important, but of course it means also that being a part of climate mitigation policy, carbon farming should fulfill the requirements of climate integrity, and also it should be economically feasible, as we already have heard. And if you think about climate integrity, it means that everything that we do to create carbon credits, they must be additional relative to a baseline, and also there should not be any leakage at the farm level or at the market level, or that should be taken into account. Of course, the requirement of permanence is crucial. It is generally thought that 100 years, everything that we have sequestered should stay there. And as we have heard several times already, measuring, reporting, and verification, this MRV is super important. We have explored these issues in a manuscript, Carbon Farming, Climate Integrity and Economic Feasibility. And here we are approaching carbon farming and economics from a point of view of contracts, carbon contracts, and analyze how credit price, contract length, and the amount of credits that the farmer can produce impact the economic feasibility. We have applied these notions then to a number of case studies. I will highlight in 3 slides something that relates to catch crops on mineral soils. But before that, when we started to do the work, the first question came out is that how can we deal with the permanence in agriculture? It's well known that farmers have no incentives or are very unwilling to make very long contracts. 100 years perspective is impossibility when we are talking about agriculture. Therefore, we need a solution for that. We need a solution that is something relating to how we account for credits from temporary projects. And we are focusing on economic solution or economic accounting on this issue. And the idea is to use offset ratios. Offset ratio determines how many emission units one sequestered unit from a temporary project can compensate. And the other thing that immediately came evident is that how can we ensure this MRV? We need scientific measurement. We need scientific verification of the management practices that we take in agriculture. And promoting it requires many practical solutions. So experimenting, checking out, and things like that. Carbon Action is developing a verification system by using a field observatory, which is an open access online platform where all the experience that can be obtained from the piloting carbon farms are reported, and it provides a place for analysis of this experience. So solving these is crucial. And how did we do that? The case of catch crops. The first thing is, of course, then to analyze how this practice can promote the increase of carbon in soils. We have measurement on that, so we can think that, okay, when we are using year after year catch crops, we can maintain the amount that we have sequestered and we sequester more. But that takes place, it increases, but in a decreasing fashion. So the black curve here indicates the concave sequestration. And we can take then over the contract length, which is on the vertical axis, horizontal axis, the average, and then we have the average annual cumulative stock increase for the to assess the basis for the credits. But this is not enough if we have a temporary project. We have to think that, okay, what happens once the contract ends? And the farmer possibly shifts to a previous management practice or to another one. But for the, let's say, the buyer or the society, one possibility is to think that, okay, the farmer comes back to the original business as usual solution. Therefore, we have to assess that at which rate the carbon possibly is released back to the atmosphere. Sometimes it does not release at all, but this example is calculated for the case where it may come back. And then we have to assess whether this release is faster, or does it take at the same rate, or is it slower? Because this impacts then how we treat this temporary sequestration and the contract that is temporary as well. And then we use the offset ratio. The offset ratio transforms the amount that we have kind of accumulated on average on soil during the contract period. And we multiply then this amount by the offset ratio to get out the amount of climate-proof credits. And the table here indicates something about this. If we have very short, there are at least two approaches to define this offset ratio. One is discounting method. It's an economic approach where we value the temporary decrease of carbon in the atmosphere, or then we have a ton-year accounting, which does the same by using radiative forcing. And using these approaches, we can define the offset ratios. And you can see that if we have only 5 years long contract, then the offset ratio is 0.137, very small. But if I increase the contract period, then the offset ratio increases. And here you can see that by just multiplying the average annual cumulative sequestration by the offset ratio gives us the amount of credits that we can sell to the market. And once this is done, then we have the kind of the climate part of the analysis done. And then we can look at the profitability or economic feasibility of carbon farming. And it's obvious that it should be profitable for the farmer to start this work. And here we can show that the profits from carbon farming depend on what is the soil carbon stock development, how long is the contract, because it defines the offset ratio, and then of course the credit price. And the figure here indicates a baseline where the farmer does not have the catch crops, the black curve there, and then the colored curves indicate how the profitability of carbon farming functions in terms of contract length and then in terms of the carbon price. So the higher the carbon price, the more profitable carbon farming will be. If it's very low, then we need a long contract to make it profitable. So in this sense, we can characterize the social conditions or the economic conditions for promoting carbon farming. Presentation is short, so meaning that there are lots of other aspects that I need to take into account, but here just generalization from the whole paper. And the first and the most important thing is that what our analysis also on the other cases shows is that the carbon farming with farmers selling carbon credits from temporary project is entirely doable. Offset ratios are the factor that are crucial for maintaining climate integrity, and the leakage issue can be handled with. The challenge is, of course, that we should get accurate data, we should have clear accounting rules and verification systems. And then this also, given that the projects are temporary, it's not only how much we can sequester carbon in soils, but how well it will sustain there. So accumulation and depletion are both important issues, as we already heard from Tanja's presentation as well. And this is the point where the Carbon Action Initiative is doing much work. And based on this, our recommendation is that if we are going to have credit markets as a solution, we could start with simple and proven management practices, because that pushes the market started, and then we can increase the practices as long as we get information and understanding, and farmers get that as well. And then there has been discussion here about accounting rules, how we should take into account co-benefits and co-damages, like Kai's presentation, and it's obvious that can be done. But it's interesting to ask that could we also include in carbon markets the aspects of impacts on nutrient loading and biodiversity. If you are thinking the general voluntary carbon markets, we often have carbon credits plus women's right, plus children's schooling. So market has been full, not within this context, but in other more general contexts, that we have the carbon and some additional aspects. And whether we should develop it into this way is a question that should be discussed more kind of concretely, but it might be an interesting option for us. So thank you so much.